Okay, today we are looking at if w equals to sine inverse of z, we want to prove that that same w will be equals to minus I ln iz plus or minus 1 minus z raised to power 2 close brackets 1 over 2 can also be square root of 1 minus z raised to power 2. Now, how is it even possible that this will give us this? Well, let's try and see, and let's play along. Solution. If w now let's write our question. We have w equals to sine inverse of z. Now bringing the sine inverse to the left hand side, it will give us z equals to sine w. And according to hyperbolic function states that when we have sine z, it gives us exponential iz minus exponential minus iz all over 2i. Now when we have this, let's now break it into this. We are going to have z equals to sine w will now be exponential iw minus exponential minus iw all over 2i. Now can you see here, when we have sine w, here became w, and here when we had z, here became z. That's how it is. So if we have something like and we have something like sine t is going to be exponential it minus exponential minus it all over 2i. Let's get that. It's not just z that is everything. You can replace everything. You can replace the z with w. Okay, let's continue. We have already found this already. Now let's now cross multiply. Cross multiplying, we are going to have 2iz is equals to exponential iw minus exponential minus iw. Now let's bring this z to this side. We are going to bring it into that side. We are going to have exponential iw minus exponential minus iw minus 2iz equals to 0. Now we have this exponential minus iw. Let's simplify it by saying this. We're going to have exponential iw minus 1 over exponential iw, just like saying 1 over x equals to x raised to power minus 1. Just simplified it, because when you have something like x raised to power minus 1, it later turns out to be 1 over x. Let's get this again. Now when we have e raised to power iw minus 1 over exponential iw minus 2iz equals to 0. Now we want to make everything a straight equation. Let's multiply through by exponential iw. We're going to have exponential iw raised to power 2 minus 1, this cancels this, minus 2iz exponential iw equals to 0. After this, we're going to have exponential iw square minus 2iz exponential iw minus 1 equals to 0. This is where the real game starts from. We can also see this as a quadratic equation. If you can see, let me break it down. We can just say x squared minus 2izx minus 1 equals 0. That is, our x here is exponential I raised to power w. So I won't want to confuse you. let's just use exponential IW as our x. Now, looking at this, we are going to solve this with the almighty formula we all know as quadratic formula. The quadratic formula which says that, looking at this, we have our A, we have our B, we have our C. Let me start it from here. Now, the quadratic formula states that using exponential IW gives us minus B plus or minus square root of B square minus 4AC over 2A. This alone is the almighty formula, or the quadratic formula. Now let's continue by saying exponential IW equals to putting in our B. Our B here is minus 2iz. We aren't adding the exponential IW because that's our x, so we are not going to add it. So that's minus open bracket minus 2iz plus or minus square root of B square. Our B square is still minus 2iz, open bracket minus 2iz raised to power 2 minus 4ac, that's 4 times 1 times minus 1, since they said 4ac, and our A is 1 and our C is minus 1, all over 2A. Our A is here is 1. And we're going to have exponential IW equals to, simplifying this, we're going to have 2iz plus or minus square root of, simplifying this side, we're going to have what? We're going to have minus 2 square is 4 I square z minus open bracket. When we have the bracket, when we simplify this bracket, we are going to have 4 times minus 1, that's minus 4. Minus 4 times minus here will give us plus, that's plus 4 all over 2. Now exponential IW equals to 2iz plus or minus square root of, since we all know that I square is minus 1, that will give us minus 4z square. No, there's a square here. When this is square, we enter this. So minus 4z square plus 4 all over 2. Now we have exponential IW equals to 2iz plus or minus square root of, let's simplify this. If just this square root alone, let's try simplifying square root of minus 4z square plus 4. We can also rearrange this to be 4 minus 4z square. That can also give us 4 open bracket 1 minus z square. Simplifying this, now we are going to have, we have done this now, we now have 4 open bracket 1 minus z square from this all over 2. Having this, we're going to have exponential IW. It looks long because I'm trying to break it down step by step. Exponential IW equals to 2iz plus or minus, simplifying, we're going to have 2 root 1 minus z square all over 2. Now as you can see, 2 is constant, 2 we just have to cancel all sides. Therefore we have exponential IW equals to iz plus or minus, we can also simplify this to be 1 minus z square raised to power 1 over 2. That's it. Now we have entered the main part. Now having exponential IW equals to iz plus or minus open brackets 1 minus z square close brackets raised to power 1 over 2. Now let's bring things down to, let's see, as we know that we can have IW equals to ln, open brackets, IZ plus or minus 1 minus Z raised to power 2 1 over 2, close bracket, close the bracket. Now looking at this, we have IW equals to ln IZ plus or minus 1 minus Z square raised to power 1 over 2. Now let's divide both sides by I. Both sides by I. Cancel. Therefore, W equals to ln IZ plus or minus 1 minus 2 1 minus Z raised to power 2 1 over 2, close bracket. This high, let's bring it back. No, we have over high. Let's not rush. Now therefore, W will now be equals to, as I said something earlier, we can also have 1 over I equals to minus I. We will bring it back up. Let's get this. It's not going to be I raised to power minus 1. No. When it's high, we're going to have minus high. That's now minus I ln, open bracket, IZ plus or minus 1 minus Z raised to power 2, close bracket, 1 over 2. This. Therefore, we have our W equals to I ln IZ plus or minus 1 over Z raised to power 2, close bracket, raised to power 1 over 2. Let's go back to the question. You can see we got the same answer. Therefore, we have successfully proven that W equals to sine Z. To prove that W equals to minus I ln IZ plus or minus 1 minus Z raised to power 2, closing bracket, I raised to power 1 over 2. Then you can also prove that W, we can also use if W equals to cos, let me write it where, if W equals to cos minus 1 Z, to prove that W equals to minus I ln, open bracket, Z plus or minus I, open bracket, 1 minus Z. No, there's no I there. That's plus or minus 1 minus Z raised to power 2 1 over 2. I'm not going to do this. Let's just do this the same way we did this, the same method, the same procedure. Please ensure we do things step by step so as to get accurate results. Thanks for watching. Ensure like and subscribe. It's not as hard as you think it is. Just know the step. That's all. Thanks for watching.